Okay, so this is on page 3 of the circuitry lab, right? Page 3? Okay, so it says, using the definition of PD, which is potential difference, given above, so it's on the lab, and the data from table 2, fill in the following. All right, so the symbol for electric potential, and this goes back to chapter 16, the symbol for electric potential is V. The definition for electric potential is what? Potential energy per charge. That's the definition of electric potential. But do we care about electric potential by itself? The thing we care about is what? The change in electric potential, which is called the potential difference. So you just put a delta in front here. So this right here, this is PD. That's potential difference. Okay? So we're using this equation to answer these questions. Okay? So the voltage or potential difference between the terminals of the power supply was, so guys, I'm just going to make up a number. Let's say you plug into your power supply and it says 8.0 volts. Okay? So the voltage of the power supply we'll say is 8 volts. This means that each coulomb, what's that telling us? Each coulomb. How many coulombs are we talking about? 1. So basically what we're doing is that this Q right here is 1 coulomb. The charge is 1 coulomb. So each coulomb gained blank potential energy. So to figure this out, take our equation and rearrange it for the change in potential energy. It's going to be the potential difference, or the voltage, multiplied by the charge, right? So the change of potential energy, so we're talking about 8 volts. Oh, and by the way, what's a volt? Well, let's figure it out. What's potential energy measured in? Joules. What's charge measured in? Coulomb. A joule per coulomb is a volt, right? So let's put 8 joules, and it's joules of what? Specifically, it's joules of what? Potential energy. 8 joules of potential energy per coulomb. Well, how many coulombs are we talking about here? 1, because it says each coulomb. So coulombs cancel, and our change of potential energy is 8 joules. So this is 8 joules right there. Okay, now we keep going, blah, 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 blah. Or, so right here now, or that each half coulomb, so what happened? We're messing with what? The charge. So instead of being 1 coulomb, now it's half a coulomb. So if you replace the 1 coulomb with half a coulomb, this becomes 4. Okay, so this would be 4 joules. Or that each 5 coulombs. So now we change the 1/2, put in a 5. So this becomes 40 joules. Okay, last sentence and then we're done. It also means that each individual elementary charge. What is an elementary charge? Elementary meaning basic. What's the building block of all charge? The proton and the electron. So it's talking about an elementary charge moving through the circuit. So it also means that each individual elementary charge gained how much potential energy. So what's the Q now? If we're talking about an elementary charge, what do we plug in for the charge? 1.6 times 10 to the negative 19 coulombs. And I'm going to let you multiply that out, right? 8 times 1.6 times 10 to the negative 19. And then that goes right here, and that's how you do it. Okay?